Oh, no, I replied to you.
Yeah, I
Yeah, yeah,
got
yeah.
it finally, but that was my second time trying.
Okay.
But I did the second one on YouTube.
Yeah, sure. Yeah, now that gives you even one more way to try to get in touch with me. I normally check my email a lot. It's just that nowadays I'm getting a lot of freaking emails. So you got to forgive me if I skip an email. Just keep shooting it at me, and I totally mean to get back to you. So if you don't hear from me, just email me again and say, hey, I just emailed you. Could you let me know what's going on? Right? Ask me something specific too. If you just give me information, I'm going to think, okay, I don't have to reply. You told me what you needed to tell me. So let's talk about formulas. And let me also say this. You obviously have been with me for several weeks now. You know how bad my handwriting is. So if I were you, I would double check all these formulas in the book to make sure that, yes, that is a square, that is not a cube or something interesting, right? Because it really sucks when you put it wrong in the formula sheet, so you get it all wrong on the test. So be careful about double checking it in the book.
How big can the sheet be?
You can bring in reams of paper. I don't care. As long as it's just formulas, no examples, no notes. If you want to put one formula on each sheet and have it like cue cards for yourself, I love it. I don't care. I think some teachers do the note card thing just so we can laugh at you, but you guys make me laugh enough already, so I don't have to force you to put on. I think I'm going to make it on a grain of rice when I get older. You have to put on a grain of rice and bring it in with you. So chapter 1 was obviously very exciting. It was all definitions, so there's no formulas really in chapter 1. Chapter 2, we got a couple formulas, but they're ones that you have to know. For example, how do you get the class width for histogram? Range divided by number of classes. I love it. So an explanation of what your class width is and why is it's not good enough to say 10 because it works nice. That's not good enough. What I really need to see is that math, right? Get the range, tell me how many classes you want to use, divide it, and see what the class width is going to be. Cool. So you can't write that down. You got to know it. That's one formula you have to know. See, anything else in chapter 2? We did tables, histograms.
You can't write it down?
No. You have to know it. Right, so anything I put on this board is going to be able to go on that formula sheet, so I haven't put anything down there yet. There was also stem plots and dot plots. There's nothing really from chapter 2. The first real formula we got was one that you might not even want to write down necessarily. It was this guy. And okay, I'll go like the book is, fine. They put a big ass N there for some reason. Remember we talked about that? N means the size of what you're looking at, so why does it have to become big if it's a population? But anyway. How do I know that's a population besides it's a big N? Because it's a freaky letter I use here, right? Greek letters for population. So what would the formula be for sample mean? X bar. Sum of x over little n. I love it. So if I'm you, I might even consider not putting those down. Because I know how to calculate an average. I don't necessarily need those formulas, but I hope that if you write it down, it doesn't confuse you, is my hope. It shouldn't confuse you. It should be part of what we're learning. Now, the main thing, what about median? There is a formula you can write down here if you do it correctly for median. What was that little formula I gave you guys to figure out where the answer was? I love it. So this n plus 1 divided by 2. And normally it's given a little d. Can you guys see okay over here? I'll write bigger. That's one bad thing about this room. Whichever board I pick, the other side of the room gets screwed. So, oh well. Cool. Do you notice how I'm not saying to find the median? I'm not saying population mean. You can't put any of those words there. If you do, you will lose points. So be careful. Don't do it. So this is what you can use to find the median. Right. So if there are 15 things in there, 15 things in your list, 15 plus 1 is 16 divided by 2. The eighth number would be the median. You go find the eighth number, that's your answer.
Is the symbol for median like the X is the squiggly one?
I like it. Yes. Cool. But that's not, the formula for median is not this. This is given a D because it's like the distance to the median. How far do you have to go into the list? That's why it's given a D. I wouldn't say X tilde equals that because it doesn't equal that. It's just where it is. Cool. So that's median. Mode is an idea. You just find whichever one occurs the most. Mid-range you can write down. This is actually one word you can have because there's no symbol for it, right? Which somebody was thinking about that earlier. You can write mid-range, you can have that word down because there is no freaking symbol for mid-range, so I have to deal with that. What is the mid-range?
High plus low.
High plus low.
Divide by 2.
Divide by 2. And obviously you don't have to spell high and low correctly. We're okay with that. Let's see, what else was in there before we get into the standard deviation and the variance stuff.
We didn't talk about the range,
Range, yeah. Range is what? High minus low. If you really want to write that down, I can't argue because it is a formula, but you guys should know how to get the range. Let me think. I think that's it from that little section. The next section was standard deviation. So if I were you, I would put down there, pick one of two ways. You can either say, in fact, I would probably do it this way. What's going to go inside here since I put that symbol there?
Sum in x and x bar.
Careful.
X minus x bar.
Careful. Mu. That's got to be a population standard deviation, right? Cool. Squared.
In minus 1.
Careful. Population. So remember, the n minus 1 was an adjustment if I only have a sample. So for the population, I don't have to adjust the damn thing. I've got everything. And the book might put a big ass n, but I don't care. Right, n means the same thing. I don't care how big it is. Okay, how are we doing so far? And of course, S would be what? I love it. Over. So now you need that adjustment, right? Put it up here. And just one really big thing the people that don't do this homework or that do this and don't show me work and they got it out of the calculator, they're the ones that are going to make the mistake on the test of trying to plug a number in here, plug a number in there. No. You replace a whole sum with that, what you get from that last column, right? One number goes in the place of this whole thing. You can't plug stuff in here. It doesn't work that way. Okay. So hopefully you're close at least to getting into section 3.3 if you haven't gotten there already. So you can get practice on that. Right. Now remember, we didn't make it to 3.4. The only thing from 3.4 that I'm going to have, that's one last formula that you can put up here, is what? What's the very last thing we talked about? Z-score. I love it. So you can have the Z-score formula. You can have both of them if you want to, but and I'll put it over there too. Now the funny thing is we're going to seemingly have like 5 different Z-score formulas. They're all the same damn thing. They're all my point minus the middle divided by how big each step is. That's the same damn thing here, isn't it? It's a sample mean. I don't care. It's the middle of what I'm looking at. Divided by a sample, I don't care. It's how big each step is for that sample. It's the same formula every time we see it. It's exactly the same formula. My point minus the middle divided by how big the step is at that time.
So we can use either one?
Officially, this is for population, this is for a sample, but the mean goes there and the standard deviation goes there. I don't care what kind of thing it is, right? It's a population or sample. You guys kind of with me? Sort of? A little bit? Okay. All right, cool. I think that's it. Anybody else have suggestions for formulas that should go on your formula sheet? Yeah.
CV.
Oh, coefficient of variation, I gave you that in the homework, but I'm not going to put it on the test. It's not actually used too often, but I wanted to show you that it's out there. And it kind of shouldn't, yeah.
Did we go over that?
Not in class, no.
Okay.
In fact, sometimes I do that on purpose. Sometimes I don't do that on purpose, but there's a reason that you have a teacher and a book. So sometimes I'll assign you homework that I haven't said a damn word about because you should be reading and looking back at examples anyway. So I kind of try to force you to do that, but give me something I didn't talk about. Yeah?
Can we write down like the standard deviation columns?
No. Good question, though. Yeah. But all you have to do there, remember, is if you cover the sum symbol, it tells you what you need to have, the column that you need.
Or like what percentage each step?
Oh, that. Empirical rule and Chebyshev's, you have to know. So you can't write this down. So I get really interesting, like people make their own, thank you, because it is kind of hot in here. People make their own little symbols for themselves. And I see stuff that's really faint, or way in the edge I see 68, 95, 99. Come on, I'm going to see that. Come on. So that you got to know, right? Within 3 standard deviations on a normal distribution, what percentage of the data is in there? 99.7. I love it. So 68, 1,
And 2 is 95.
2 is 95, 3 is 99.7. I love it. Chebyshev's I'm not as big on, but you still should know within 1 there's at least nothing, which is saying a lot. Within 2 there's at least 75. Within 3 there's at least 89. Cool. Because I will give you problems just like in the homework. They give you a mean and they ask you what percentage is between here, or between what 2 things would you find, 75%. So I'm going to ask you exactly the same way they did in the homework. If you haven't done the homework, then you have no idea what that is yet. But hopefully you will very soon. Okay. I'm pretty sure that's it. Yeah. Variance is kind of up here inherently. I saw a few of you guys in the homework, you would find the standard deviation and then you would square it. The better way is just to realize this, before you square root, is the variance. You got it already. When you square root it, it becomes the standard deviation. Yeah. For right now, the variance doesn't mean much to us. It's like a middleman. So later we'll see what importance it has. So if you wanted to, you could put a whole separate sigma squared equals and take the square root off, but it's not really necessary. Yeah. All right, cool. Okay, good. So please understand that if you do this, you will lose points, minus whatever. No explanation, no words, no notes, but you can certainly have the formulas. Yeah.
Is this optional for entry? Or we have to
Oh, sure, hell yeah, man. If you don't want to put together a formula sheet, I love it. That's awesome.
And second question. On the test, are you going to specify if it's population?
I have to.
If it's not, then we'll assume it's...
If you can't tell, if I don't say something that makes you know it's a population or a sample, what will you assume? Sample, because that's what we normally use. I've got to be really clear when it's a population, because it's normally a little weird to have an entire population's worth of data. Okay. Yes?
Are you doing any of the weighted?
No, I just threw one problem in there like that just to show you. Because it is the way that a lot of people grade their classes. You guys should know that anyway. Yeah.
I have a question about the practice test.
Yes. Okay, cool.
On number 1F, do we need to do that? Because I don't think you did it on...
Exactly. What did I say last time? Remember 1F?
Cross it out. Okay.
No good. Yeah, it'll be on the test after this because we haven't gotten to 3-4 yet. And 3-4 is where we talk about percentiles. Like I was talking last time about the SATs. And now they tell you what percentile you scored in. That's the next step for us after this test. So homework up through 3-3 is due this Thursday. 3-4 we'll do the next test.
Can I ask you a question on homework?
Yes.
3-3, I didn't really understand how to do 22.
It was like a lot of words.
Huh?
It was a lot of words.
I find the urge to say aw. No, 22 is not a lot of words. 22, right? And 3-3. So that's the one about the Miss America, what they used to be like in 20s and 30s and what they are recently. So
I didn't understand find the coefficient of variation.
gotcha. And somebody else asked a question about if we could put that up on the formula sheet. That's something I want you to do in homework and also to go back and take a look. All the coefficient of variation is. That's funny. The coefficient of variation, if I told you that the standard deviation for a set of data was 1,000, would you say that's a big standard deviation? But what if the mean was 18 billion? Is that 1,000 a big standard deviation now? See, so it's relative to how large the data is. Like 0.002, is that a large standard deviation?
No.
The correct answer, hopefully, after the first thing is, I don't know, Jeff, because you haven't told me. What if the mean was 0.00002? Then 0.002 standard would be huge compared to that, right? So this is a relative measure of how big the standard deviation is relative to the rest of the data. So if I get the standard deviation and I divide it by the mean, that's the coefficient of variation. So the smaller that thing is, the smaller the standard deviation is relative to your data. And the bigger that thing is, the bigger your standard deviation is relative to your data. So that's all the coefficient of variation is. Right? So for example, if I had a set of data where the standard deviation is 2, but the mean is 0.5. Is that a very large standard deviation relative? And then when you plug it in, you get 2 divided by 0.5 is 4, right? If I had the same standard deviation 2, but the mean was 20, now the coefficient of variation is 2 divided by 20 is 1/10. 10%, right? Not a very large. This coefficient of variation would be 2 over 0.5 would be 400%, whereas this is 10%. So it gives you a quick way to compare, sort of like what I say, if you found $1 on the street, it's huge to you if you're homeless. But if you just got your $1 billion check and you see $1, good, I need something to start a fire, It's not going to be very important to you. So this is sort of like what that is. How big is that standard deviation relative to what you got already, your data? So that's all that is. And I'm not going to test you on it. I had to give you a homework problem on it just so you knew it existed out there in the world. But I'm not going to test you on it.
So on those, you find the standard deviation first.
Exactly. Find the standard deviation first.
Do that.
And then do the coefficient of variation. And then I'll help you. Because if you just find the standard deviation, you really can't compare them legally. Right? If you find the coefficient of variation, then you can say, okay, one is definitely bigger than the other or not. Because obviously part of the point, I think that same problem was back in section 3.2 where they asked you to do the mean, right? If I remember correctly. And obviously the average weight has gone down since the 20s and 30s because the cultural acceptance of what defines beauty has changed, right? But the spread amongst them, this is what that's analyzing. Has the spread changed? Has the variation in the contestants changed? That's what this is looking at. Okay. So just because this is our first review day, I don't have anything planned beyond what I've already done. So it's really up to you guys. If you have quizzes to correct, homework to finish, now's the time to do it so you can call me over to get some help. If you want to do some problems up on the board, you can ask me to put some problems up on the board. We could do some examples in the calculator. I can throw that up here on up on the overhead, right? If you want to do a standard deviation example or something.
Yes, let's do the calculator.
What's
I have a question about mode. If you have, say you have data points and like one of the numbers was repeated 3 times, the other number is repeated 2 times, would the mode be both those, or is it one that's repeated
You have a
the
clear
most?
winner then, right?
Okay, it's the one that repeated the most.
It's only bimodal or trimodal if there's ties.
Okay.
If there's 8 7s but there's 10 12s, then 12 is the mode because
Okay.
that's the winner.
All right.
Yeah. Okay.
Let's do the calculator.
I'm going to go out on a limb here and say we can't use calculators to calculate standard deviation just by plugging it in. We have to do it by hand on the test.
Yes, you got to show me just like I did on the answer key for this. If you look on the back, it's got all the number 1.
Okay.
So I'm going to want to see that table. Yes. Cool.
Well, we cannot use calculator.
You can definitely use a calculator in the lists,
Okay.
and you can certainly do one variable stats and check your work. But you can't do one var stats, write it down, and think that's good enough. I've got to see the table, and I've got to see the formula being used, right? Just like on the answer key. After chapter 3, after this test, you're never going to have to do standard deviation tables again. Which is why in the homework, some of you guys got that back and it says redo, because you didn't show me any freaking work. I got to make you do it now, because I'm not going to make you do it later. Yeah.
I have a question. When we do corrections on homework, do you want us to turn in our original homework?
Yes, so anytime you do any corrections to anything, the original and the correction. Cool. Yeah, sorry. No. No, yeah. You were like, I'm not sure how they reacted to that.
Number 34 on
34 on 3-2? 3-3. So the author's generator, this is page 113. That looks like they're really good. All right, guys. Everybody got this here? I got a good shot of it here, too. And like I said, you should double check all these formulas in the book. So this problem says the author's generator produces voltage amounts with a mean of 125 volts and a standard deviation of 0.3 volts. The voltages have a bell-shaped distribution. And they tell you this. I'm not going to be this nice, by the way. They say using the empirical rule. We know we can do that because it's normally distributed, right? What's the approximate percentage of voltage amounts between blah and blah? I'm not even going to look at the question yet. Who remembers the thing I said you should do when you get this kind of problem? What's the first thing you should set up here? Draw it out. If you wanted to, you can draw a little wee. Or it goes right in the middle.
Mean.
The mean. Not zero yet. We haven't made them z-scores or anything. But so what goes right in the middle? 125. Now your standard deviation is 0.3. So what goes like right there? 125.3. And just to get you guys used to this, if I put this underneath, do you see what that means?
Yes.
That's really what you were talking about. That's one step up. That's a z-score of 1, isn't it? Because I added 0.3 to this, so of course that would be a z-score of 1. One step away. And of course down here would go, let me give myself some more room. Yeah, 124.7. And what would go beneath that? Negative 1. I love it. 1 down. 1 up. 2 up. 2, 3. Yeah. And then 1 more down. What was it? 0.3? Thank you. And 124.1. Now you can answer any question they throw at you, right? So then you look at the question, and it says, what percentage is between 124.4 and 125.6?
95%.
95. It's a normal distribution, so we're using an empirical rule. So I don't want to see any 75s or 89s. That's Chevy Chev, right? Normal distribution, I can use empirical. It's either going to be 68, 95, or 99.7. 68, 95, 95, cool. So 95% of the data will be in there. Yes, sir.
So are you gonna tell us if it's normal or not?
I have to, yeah. If I didn't say, you have to assume it's not.
It's not normal.
Yeah, if I don't say it's normal, you have to assume it's not normal. Do you guys see what I'm saying? Because to have a normal distribution is like a really freaky thing. It doesn't happen automatically for a lot of data. So I've got to tell you it's normal. If I don't say it's normal, you got to assume it's not. You're like, oh shit, I don't know what the hell it is then. Yeah. Yeah.
So if it's like on the ends, it's going to be 99?
Good, because that's 3 away.
So
The empirical rule says within 1 is 68, within 2 there's 95. If they would have said this and this, that would have been within 3, 99.7. Is that what they say next? Yeah. 124.1 to 125.9, that would be 99.7%.
Wait, can you repeat what you said between 68 and 100?
Within 1 is 68%. This is on page page 106. They have a nice little picture there at the bottom. Within 1 there's 68. Within 2 there's 95. Within 3 there's 99.7. Bless you.
You said 68.
68 within 1.
Oh, no, what page? I'm sorry.
Oh, page 106.
Oh, okay.
Yeah. So let me ask you this real quick. Do you guys think it would be unusual to get 126 volts out of this thing? 126, would that be unusual? Why do you say that? Yeah, there's only 0.3% of the data out there. So to do that is like a 0.3% chance that happens. In fact, officially 5% chance is going to be considered rare. It's going to be considered unusual. So anything that's outside of here, anything out here or out there is going to be considered unusual. And that's the way it is right now. Later we'll get more specific with that, but right now that's pretty much the way a lot of things are done. So this could be evidence of, like, if the normal average on a test is something and I get a group of people that score up here, I go, that's evidence that something's weird about that group of people, or they studied more, or they're smarter, or whatever. Because it's unusual. It's not what I expect to see. Right? So that's what we're working towards. What's good enough evidence to show something? Okay. Of course, that's beyond what they asked you. That's all right. Any other questions from homework, or?
I got one, but I don't really. I just need a quick question.
Okay.
Wait.
Oh yeah, there. So the barrels are no good, so redo it so it's good. Make it into a bar graph. So just so everybody makes sure, I always want you to get something out of these review days. So I'm sure you've either got homework you haven't finished, quiz corrections you still have to do. If you haven't tried the practice test yet, you can try that out, right? Questions, cool. We can do stuff on the board. You have stuff to do, right? Yeah.
Number 34 and 3.2.
3-2.
Yes.
34? Oh yeah. So, we talked about that one before. That's the weighted mean, and that's the way I do my class. Some classes have points, like the midterm be 500 points, the first quiz would be 50 points. You've seen classes like that. But then you have the classes like mine, where I say, 25% final. I can't remember, 20% quiz and homework. And what was it? What did that leave me? 55% tests. I can't remember if that's the way I did this class, but oh. So how does that work then? I mean, if you average on the 3 tests, if you averaged an 81, and on the quizzes and homework you averaged 89, and on the final you had a really good day, you got a 92. How the hell do you figure out your average? Do you add them up and divide by 3?
No, you add the percent of 55 plus people.
Exactly. So you would do 55% of 81 plus 20% of 89 plus 25% of 92. And that would be your average. The funny thing is we already do that. If I have like the tests, real quick, I want you to really see this math. If on the tests I got an 80, an 81, and an 82, right? The average there would be 81. Let's pretend like you can't see that. How would you do the work? You would do 80 plus 81 plus 82 divided by 3, right? Are you guys, now, I desperately want you to realize you don't have to do what I'm about to do, but I want to show why that makes sense. If you have 3 tests and they're all equally weighted, how much weight does each one get? None of these tests mean more than the other one, right? As far as your grade. They're all equally weighted. So how much weight would each one get? Same amount, which is what? 33.3%, right? 1/3. 33.3. You guys with me? Because they all get an equal amount of the whole thing. So isn't that, what do you get when you do this? What's another way to do this? 80 divided by 3 plus 81 divided by 3. Isn't mathematically that the same? Would you ever do that? No. But I'm just trying to show you why that makes sense. Is this 1/3 of 80 plus 1/3 of 81 plus 1/3 of 82? Right? So you do it already. You already weight each one. They're equally weighted, so it doesn't show up as freaky. When they're not equally weighted, it looks weird, but it's exactly what we do already. This guy is worth 55. Okay, 55% times him. Plus 20% times this guy. Plus 25% times that guy. That'll be your average. Okay. Does that make sense? A little bit? The weighted mean stuff, there's a whole chapter coming up that we're going to do a lot of stuff that look like this. It's going to make, it's going to be a different way of looking at it. So we'll focus on this kind of problem later. Yeah?
How do you multiply by percentages on the calculator?
Just put 0.55 times 81.
Oh, okay.
Don't put 55 and then look for your percent symbol.
Okay.
That's way gone. Make a percentage into a decimal before you throw it in the calculator. Yeah, cool. Yeah.
I have to redo it.
I know, I just want to
And then everybody's got a spot. Oh, it's Heidi. Maybe it's, oh yeah.
For standard deviation.
I love it.
On these, I didn't write down.
That's cool.
All
Just
right.
the numbers are good.
Okay.
Thanks, man. Oh yeah, staple the corrections. Don't staple new homework to corrected homework.
Okay.
Cool.
Which one do you want on top?
Oh, the corrections. Yeah, cool.
First one.
Otherwise, I'll think that I just never gave it back to you. Like, oh crap, there's corrections back there.
Okay.
Oh, you have it in there?
The key says?
Cool. Oh, on the back is number 1.
Do you want to just like put it in this file too?
Yep. Oh yeah. Cool.
No, for these, you want us to show the deviation of some of them?
Yeah, and it's real quick. Just show me the little formula, sum of x over n, and then whatever the sum is divided by the number.
Okay.
I'm only gonna make you do that in chapter 3, but I just need to see,
No,
like,
I did the other one
median.
and I didn't expect
Some people are just putting the whole list and then showing me, circling the middle 2 or whatever, and that's good enough.
Yeah,
for
but
the
there's no
median.
list on this one. It's mid-range, mode.
Oh, but there is a list of data. So show me how you got the median, show me how you got the median, that kind of thing. The mode obviously will work, but
Okay.
the mid-range is good, but it needs to work for those guys.
Okay, no problem with that. And then the last question is, wouldn't this be more of a random and cluster? Because it didn't say like you're picking.
Well, all from some. So you pick some hospitals, and you take all the patients from those chosen hospitals. So I mean, it is random. Cluster is random, but it's more than just random. It's specifically clustered. That's how I got my random samples. Right. Stratified would be if I took some patients from every single hospital.
No, right. No, I thought it was more of a random. Okay.
Yeah, so it's sort of like the part A, same idea. Randomly select classrooms and take
Yeah, it
everybody
was just
from
more
the
obvious on this one than that one.
Gotcha. It's
Okay.
just like replace hospital and classrooms. It's just really the same problem.
Understood. Okay.
Oh no. And guys, on I forgot to make this point. Your histogram doesn't have to look like mine if you picked a different number of classes, right? I'm not saying that you had to do it exactly like this, but I want to give you some kind of representation. So if you pick 6 classes, yours will look differently. And yours is still like very loosely normalized. It looks like it's actually flipping solid. Oh yeah. Oh yeah. So this gets really kind of boring. But no, this is perfectly valid. You don't have to do it the way I did it. Cool. Thank you. Yeah, I know it's weird.
The 34 that you studied,
Yes.
I can't do, how do you do like the averages of all the questions?
I think they just give it to you,
Does
right?
it give, but then,
Oh, she gives you
add
these.
them all up.
Add them all up, divide by 5.
Oh, okay, that's right.
Because they're all equally rated.
Okay.
Yeah, cool.
For this, it says L1 squared, and then this one says.
Oh no, this is from the Calculator Bible, and this is just generally how you can do stuff.
Okay.
But
this is
specifically, I
right here.
want this. In
Okay.
there. Yeah, good.
And then for these, I have to redo all of them.
Let me see. Well, you got this, but you gotta give me. You gotta give me. Yeah, you gotta give me more data. You gotta give me what these were before you add them up.
Okay.
Yeah.
Oops, sorry.
So you could even just list it out. Doesn't have to be in the same
Okay.
format exactly, but yeah.
On these,
Mm-hmm.
I don't know why those numbers are on.
Do you have your 2-2?
Yeah.
So if you choose the way the book does it, you have to use
so I
boundaries.
should just change it with inequalities on that, probably. Huh?
So you could, yeah, like if you do the corrections for this, you could just say,
Like this.
you could just take this and just rewrite it as inequalities for each one of these, and just say,
Change
and
inequalities.
just say real quick, instead of change scale, I chose to change.
But do I need to
the table.
rewrite this whole table, or can I
No,
change
no,
it in
just
this?
change that. Yep.
Okay, and I have one more question. On this is what you talked about in class. So I don't know.
Oh yeah, and
Doesn't matter.
I wasn't really being too evil here. It's just it was more of an estimation, so
Right.
it was close.
But these are what I should change.
Those are what you should
Okay.
change. Yeah, cool.
So much going on here. Like I'm doing
For the
training
chapter,
work too. So
we
so
have
much.
finished online in the summer.
Say again?
It's like
I
trying
have finished chapter 3 homework.
Oh, good. Okay.
But I miss one question. So is a kind of little thing had 3 sections all the for the stupid word problem again. This one I got 99.4.
Okay.
I cannot collect. I already did 3 times only one.
Oh yeah, yeah. I say 90.4 is pretty good. So, yeah.
I'm done for.
For the homework, you're good. Yeah, you've already turned it in electronically, so that's good. Cool.
I was thinking.
Oh yeah.
I think they got your name wrong.
No, my first name is John.
It is? Why
Yeah.
do you go by Jeff?
I just always have since I was a little kid. Because my grandfather's John, my father was John. They're like, enough Johns already, you're Jeff,
I
right?
was so
Okay.
confused.
I know. I even signed John. My official things. Oh, what is today?
It's the 20th.
What would this be? This one. Ordinals? Does it matter? Order. That it goes in. Yeah.
Okay, cool. Thank you. Yeah.
Actually, I'm kind of behind, so that's because I'm going to today and I started all over again from the beginning.
Okay.
So, it's